Welcome to another lecture from ecopoint, and this is a set of 5 questions, and try to do it in minimum stipulated time, 5 to 10 minutes. So question 1, 2, 3, 4, and 5. Question number 1. Suppose you are testing a null hypothesis about the population mean. Null hypothesis H0 is mu equals to mu naught against the alternate hypothesis that mu is greater than mu naught with population variance given. The computed value of the test statistic is ZC. So that is what is your test statistic. What is the p-value for this test? Where phi is the cumulative distribution function for the standard normal distribution. So yes, since you are testing mean and variance is given, so this has to be Z statistic case. That is, you will be using Z statistic to find out, to work on that hypothesis. This is one tail test that has to be used, so that because your alternate hypothesis is mu greater than mu naught, so right tail test. So the p-value basically is the probability on the right of the statistic. So therefore, that way should be equals to 1 minus the cumulative till the test statistics. So C should be the correct answer. Next quick question. The power of a test refers to, it's a very common question asked everywhere. Is it type 1 error? Is it type 2 error? Is it 1 minus type 2 error or 1 minus type 1 error? Well, the power of a test is 1 minus beta, that is 1 minus the type 2 error. That is what is power of the test. Type 1 error is basically alpha. So type 1 error is the probability that you reject the null hypothesis when actually null hypothesis is true. Type 2 error is equal to the probability that you accept the null hypothesis when actually it is false. That's why it's an error. And your power, and the power of the test is basically 1 minus beta. This is beta. 1 minus beta is essentially that you are able to reject the null hypothesis when it is in fact false. Next question. Next question. You have to match the two lists. In one list, you have the variable, and in the second list, the distribution. So, well, the first one is sum of squares of independent standard normal variables, variates. Number 2 is ratio of standard normal variate to square root of an independent chi-square variable divided by its degrees of freedom. Next is ratio of two independent chi-squares, which each divided by their respective degrees of freedom. And number 4 is normal variate minus its mean divided by standard deviation. Well, this clearly is Z. Ratio of two independent chi-squares divided by their degrees of freedom. So chi-square, if it's chi-square 1, and say degree of freedom is m, so divided by m upon chi-square 2, say degree of freedom is n, so divided by n. Well, this, my friends, is f. So this is f, and ratio of standard normal z upon the square root of chi-square divided by its degrees of freedom, say n minus 1 is degrees of freedom. This is t distribution. And sum of squares of an independent is chi-square random variable. So, well, this means that, okay, this means that number 1 goes to its chi-square, so it is number 4. It matches to 4. B goes to T, so that is 1. C goes to, it is F, so F is 2, and D goes to standard normal, that is 3. So it's going to be 4, 1, 2, 3. 4, 1, 2, 3 is option D. Next question is, consider the following statements. Union of finite number of closed sets is a closed set. The empty set of an open set, but not a closed set. Every infinite set is an open set. The intersection of finite number of open sets is an open set. Well, now which would be the correct option here? Union of finite number of closed sets is closed. This is true. If you take finite number of closed sets, this comes from a theorem. If you take finite sets, finite closed sets, F1, F2 till Fn, the union of finite number of closed sets will be closed. Infinite number, you cannot say. The union of finite will be closed. The empty set is an open set, but not a closed set. Well, empty set is open as well as closed, actually, because it is vacuously true. For it to be a closed set, so definition of a closed set is F is closed if and only if its complement is open. Now, phi is open. The complement of phi is entire R. R is also open. So since the complement is open, therefore it is closed as well. So this is not correct. Every infinite set is an open set. Every infinite set is an open set. No, not every infinite set is open in nature. You can take any closed interval. If you look at it as a set, it is actually an infinite set. It consists of infinitely many real numbers, but it's not an open set. It's closed interval, so it's a closed set. The intersection of a finite number of open sets is open. Yes, absolutely. The intersection of finite number of open sets is actually open. These two things, these two statements are actually coming from a theorem in real analysis. And so C should be the correct answer. A and D are definitely correct. Next question from matrices. So A is 2304, B is 2015. Which of the following is not correct? A transpose B turns out to be this. A plus B transpose turns out to be this. See, A plus B is very simple to do. A plus B. So in this question, they're talking about A plus B. They're talking about A transpose B, the product. So it's a quick calculation. A plus B is simply 4, 3, 1, 9. Is it anywhere close to this? The transpose of this is yes, absolutely. This is actually correct. We want not correct. So this is correct. So this is not our correct option. A transpose B is equal to 2304 multiplied by 2015, which will give us 4, 0, 10, 20. So hence A is also actually correct. B is correct, A is correct. So C clearly is not correct because it's 4, 0, not 0, 4. So the correct option is C. You should always be very careful with the questions that are asking for the false statement or not correct. And these are very important ones. Thank you very much. I hope this will really help you guys. Thank you.